Hi, good morning, and welcome to the ZP Developers Zone. So we do this Developers Zone every Thursday at 8 a.m. London time. Now, I know it's a little early today. We're something like 21 minutes early, and I will explain that because we're actually doing some workshops today, so I have to come online early and do that. So let me jump straight into this and say that we have our ZP Academy. If you're not familiar with some of the techniques I'll talk about today, which could be voltammetry, potentiometry, penis spectroscopy, uh, voltammetry, etc., then please check out the ZP Academy. There's a couple of free courses on that. And so if some of the techniques, like I say, are not super familiar to you or you want to get a better understanding, then please go to the ZP Academy. We do webinars. We're having this webinar every Thursday at 8 a.m. London time. So when questions come in, which really have a technical nature, then we like to answer them in this webinar. So this webinar, kind of the intention of the webinar in some ways is to support the community a little bit, mostly academic, but we also support the commercial community as well. We do have collaborations. We've got something like 5 PhDs running at the moment, so our collaborations are very strong. We do like to post jobs also through kind of things like the webinar, because we want to sort of obviously hire the community. We have our ZP Developers Zone website, and we have our workshops. So as I said, and as I apologize for, we have started this slightly early today, and that's because at the moment we are having a series of workshops. So we did last week do some workshops in India. To be frank, they were really good. We had a great attendees. They were very engaged. So in those workshops, we do live demos. The attendees do live demos. They make their own biosensors. They test their own biosensors, and we give them a really comprehensive introduction to the kind of commercial and technical aspects of biosensor development. This week, we're doing the same in Norway. In a couple of weeks' time, I think it's actually next week, we'll be doing one in Coventry, and then we'll be doing one in France. And then we're actually getting into, and if I throw up a link, I'll also try and put the link underneath the video as well so that you can sort of find these things. So workshops are a big thing at the moment, and we're also opening up a 2023 schedule as well. So a couple of workshops will be going in there. I think we've put one up that's completely online, so I'll mention that. We appreciate that even though we have now held workshops, at least on 3 continents, we've held 2 in India in the last week. We've held 1 in the USA in the last essentially month, and we're holding something like 3 in Europe in the either now, well, in December essentially. So we do have a lot of workshops. We understand not everyone can make it. I'll go a bit quicker because I realize time is short today. But we're also holding one that's just purely online as well. So just know that in 2023 there is an online workshop on the 10th of January. It's purely online, but we won't be just a workshop. We'll be doing live experimentation as well, so you can sort of see the experiments performed in front of you. So first of all, I've got about 7 questions here. The first question is regarding ion selective electrodes, which are a form of potentiometric sensor, and we do cover these in our workshops, and whether we can look at these sensors using voltammetry. And the answer is yes. It's quite an interesting idea actually, and we haven't done it, but I'll discuss it. I do appreciate people struggle with our rectangular electrodes. I have done webinars why our electrodes are rectangular. It's really, and I know I said it before, but it's really because we're actually thinking about the commercialization of these electrodes and not just the R&D of them, but I'll talk about it. We've also had some inquiries about our Troponin I sensor. I'll just talk about that. Also biosensors for bioreactors. I have done some webinars on this recently and mentioned that we have a facility in Coventry, which is next to Warwick University. And because of the strong connections to Birmingham and Aston and Warwick, we've actually got some PhD students as essentially alpha testers at the moment on that. We're measuring pH in wounds. That's some inquiries that have come in. pH measuring in wounds is a really hot topic at the moment. I think there's a real, I want to call it almost, I don't know, an arms race, but it's definitely a race on So who's going to be the first one to do this and commercialize this? pH sensors in general. I had some inquiries about connecting to pH sensors, and then some custom electrode inquiries as well. Right, so 7 questions. So the first question is about our sodium and potassium sensors, which are, we often use them as potentiometric sensors, and the question is, can I use them as voltammetric sensors? I will discuss it because we have a lot of potentiometric sensors: redox, pH, chloride, potassium, calcium, sodium, phosphate, nitrate, ammonium. They're all forms of ion selective electrodes. The ion selective electrode has 2 main components: a reference electrode and a electrode that's been functionalized with an ionophore, for example, and we measure the voltage between them. And the voltage between them then is essentially the potential. I should say we measure the potential between them and the units of voltage. This is a very minor detail, but strictly speaking, you measure potential and the units are voltage. You measure current and the units are amps. People often mix those 2 things up. I do as well, no big issue. Anyway, so we have 2 electrodes and we measure the voltage between them, and it's we call it measure the potential between them, I should say, and it's a potentiometric measurement. So when the correct ionophore, for example, potassium is present, then it'll bind to its, when the correct ion is present, it'll bind to its ionophore and we get a signal. This is covered in great detail in our workshops. We just did it yesterday where actually everyone was doing a pH demonstration. So we gave them a pH sensitive electrode, and in the example of protons, there's a delta plus in potential, and in the presence of an alkali that can take protons essentially from the electrode, then we get a minus, a delta minus. So essentially it's the movement of these ions that changes the voltage on the electrode, and that voltage is proportional to, that potential rather, is proportional to the ion of interest. Now the question is, can we do voltammetric measurements on these? This is just an animation of a very standard ferrocyanide voltammetry. I've just sketched in that actually if you did the voltammetry on an ion selective electrode, you wouldn't have these oxidations and reductions. You'd have a signal that was much more indicative of a capacitor. We've never really discussed capacitors in any of these webinars, but in answer to your question, I think actually the capacitance of these electrodes would change with the binding of the ion, be it sodium or potassium, into the our sensor of interest, and you see a capacitance change. So the answer to your question is yes. I've personally never done it. At ZP, we've never done it. But when you first asked the question, could we look at this, these electrodes using voltammetry, I was thinking, it made me realize you possibly could. It's just people typically don't. But just because people typically don't, it doesn't mean you shouldn't try it. Something that just slightly occurred to me as well, is I'll try and bring it up very quickly, is you probably need quite a, because I was going to expand the answer to your question and actually say, not only do I think you can do it by voltammetry, I think you can also do it by impedance spectroscopy. So I'm just going to drag on and say you possibly need, to do R&D on this, you probably need an anapod, not probably, you do need an anapod EIS. Anapod EIS would be the one I would recommend, because you do, if you want to try out these sensors using voltammetry, and I would also suggest you try EIS, impedance spectroscopy, then I think you need, in an R&D phase, you need an anapod EIS. So I will drag that back off now and essentially get on with the webinar. But the quick answer to your question is yes, it's an interesting idea, and I think it could actually work. I've not done it, but I'm a fairly bold sort of scientist. I think I could actually make that work, and I could also make it work with EIS, electrochemical impedance spectroscopy, as well. One of the questions was, what's the selectivity of ion selective electrodes? I haven't done it yet, and I will try and do it over the course of the day. I do want to put these links underneath the video, because we do have a web page about the selectivity of ion selective electrodes. Now, that selectivity is based on the idea that you're using potentiometry, and I haven't I wonder, in fact, if you're using impedance spectroscopy, you'd actually be able to improve that selectivity. I've got all sorts of theories why. Impedance spectroscopy is very feature rich. You can get both the capacitance of the electrode and the resistance of the electrode. So I'm really tempted to say you might even be able to improve it with impedance spectroscopy. But in answer to your question, I think the unselective electrodes are pretty good. But take a look at this page, and that will give you some background information upon it. Again, I'll go a bit quicker as well. We do have a workshop today, and I do need to attend it. We had a bit of internal discussion about this because I know people like these circular electrodes. I'm not a super fan of circular electrodes. This is even one of our products, and I'm not a super fan of it. But the reason people like circular electrodes is they can just come in, they can pipette down, and the drop just spreads, and it's really kind of easy for them to functionalize. And there we are, offering up these rectangular electrodes. And I saw yesterday one of our guys really do a great job. In fact, we had a workshop yesterday. Everyone did it. We pipetted on, but what I sort of discovered is that I think I've sort of wrongly told people in the past, pipette on 3 drops. Now this is generally how we do it. But one of the guys said, look, it's slightly easier to actually put on 1 drop like this, and then if you're doing hand work, to put 1 drop on like that. And I think they suggest a drop size of, it's really small, but 0.5 to 0.9 microliters. So 0.5 to 0.9 microliters. They put a drop on, and they drag the drop. They sort of essentially paint the drop across the electrode using the pipette tip. That doesn't mean they scratch the electrode. They just guide the drop across. So I have, like, if we're using our robots, we come in, no probs, we can do that. If you're struggling to keep the material in place, then go for a smaller drop size, 0.5 to 0.9, and you guide the drop or spread the drop across the electrode with a tip. I saw one of our guys do this, just hand do it, absolutely beautiful. Of course, at ZP, you have people who sort of essentially specialize in different parts of processes. So in fact, people get really good at, definitely certain aspects of this. So let me go a little bit quicker. Question number 3 was about somebody wants to do some troponin research. Now, the troponin sensors we really only make them available to big clients or into clients that are really well funded. These are they're not straightforward sensors, and they need a lot of support from us. Just to say, this is not the troponin sensor, but what we've done in the troponin sensor is take the electrodes, we've functionalized it with an antibody, and we read it by impedance spectroscopy. Now, we do cover this in some of our workshops, and I actually described this particular experiment in a workshop. But the answer to the question is the Troponin I is not something that we readily sell and support on the website. It's something that we use on client projects. It's based on a recognition molecule that's been attached to the electrode, and we've then stopped what's called non-specific binding, and we tend to read the electrode by electrochemical impedance spectroscopy. These are some of the slides from our workshop. So if you're not familiar with EIS, I do have some videos online, but we also do go through this in quite a lot of detail about the meaning of these signals and how to interpret these signals in those particular workshops. So in answer to your question, Troponin I is not something that we're able these days to just sell on the web store. It's there, but we do use it on client projects. It's essentially like an immunoassay, and we read it by EIS. So those are the details I'm able to give. But of course, if people want to come and do some large projects with us, then we'll be happy to discuss, well, not discuss, but they're happy to discuss it on the actual project itself. Question number 4 is we are, I have mentioned it, we are, for example, putting our biosensors into bioreactors. What we're specifically doing is putting our biosensors into bioreactors that are being used with stem cells. And we have a couple of sites around the world. Today I'm sitting in Norway, but next week I'm on the Coventry site, and so Coventry is on the Warwick campus. It's really useful because you've got Warwick University, Birmingham University, Aston University, super little cluster. So we're really able to get out, and actually there's a lot of people doing stem cell research for therapeutics, or stem cell research for I want to say sort of alternatives for meat production as well. So we are able to kind of get into those kind of communities, and we're doing, taking our sensors and we're putting them into bioreactors. I mean, I personally have been working with bioreactors on and off since about 2005. I didn't realize I would come back to them quite so much in my career, but we're back again. So we're looking at glucose, pH, oxygen, maybe even trying to look at cell viability. But at least in the first instance, glucose, oxygen, and pH seem to be the easiest ones to target, and we are doing that. We're taking our very solid state kind of sensors and putting them and instrumentizing these kind of reactors, and it's something that's going on. Now, we do understand the whole issues about sterilization in these kind of reactors, so that's something that we're taking into account. But the answer to the inquirer is we will open up a beta tester program, but that beta tester program is not open at the moment, and we're just testing with essentially ourselves and with some alpha testers. So the beta tester program is not open at the moment. We do get honestly, at the moment, I think there's been a real sea change in people wanting to make smart wound care solutions. And so at ZP, we do get a lot of inquiries around this. And what's kind of nice is, we have these very solid state sensors. We can do oxygen and lactate and uric acid and pH and purines. And all of these have been indicated to be indicators of the healthiness of a wound. So for example, if the wound is in a sort of alkali stage, pH 8, 9, I don't know if it goes as high as 10, but if it's in that kind of state, then it may be considered to have a problem. And if it's more like pH 5, then it may be considered to have a problem. And what I've realized is that actually the pH sensors we have today, on paper, they look good enough already to do this. And the reason I say that is because here's a sensor being tested at pH 4. So the signal is down here. And here's a sensor being tested at pH, I have to lean in a bit and look at that, about almost pH 10. But it's a massive signal. So it tells me that the easiest things to work on in life are those that intrinsically have quite a large signal. So the difference between, let's say, a healthy state and an unhealthy state of a wound, if we're looking at the pH signal, is actually quite large. So that actually gives me quite a lot of confidence that this is not so hard to do. So at ZP, we obviously have a whole bunch of components around this, the sensors, the microfluidics, the ability to not necessarily adhere to the skin, but get those sensors into some sort of skin-like environment. We obviously have plenty of electronics around that. I have said it in the past, but really to do this kind of work, we'd have to be doing at least an accelerator program. For us, we also call it proof of principle, where we can take one of our sensors off the shelf, put the relevant electronics on it, do the app development. The app development is quite simple, and then we're straight into Julie, and Julie already exists. So when I look at, if somebody said to me, I want to do a prototype, I say prototype, but not minimally viable product, because minimally viable product would suggest that you could then just give it to a clinician, off they go. You could give it to a clinician, but it's the reliability I'd be concerned about. But taking one of our sensors, putting the correct electronics on it, making a connection between the electronics and the smart device via Bluetooth is really no issue. Because then we have the Julie backend already, which is a cloud database system that we have. So we would have the Julie backend already, and then we're able to send our data straight to the cloud, from millivolts converted to pH, and and even give it a sort of, a traffic light system as to whether, it's healthy, unhealthy, or needs some sort of interference or some sort of checking on it. Question number 6 was, it's much more standard actually. First of all, if you're thinking about using our pH sensors, it's probably worth saying that we do have a set of electronics called Sensi-All that we would support on our pH sensor. There's a few versions of the pH sensor up there. I'm really going to suggest that people go for the hyper value version. In the long run, this is something that we'll be able to scale much easier. The other one's on ceramic. Ceramic is just intrinsically lower cost and more expensive to manufacture, but I prefer if people went on the hyper value platform, and also connecting to it. We do have a whole bunch of connectors, and I do have a link to those connectors. What I want to say on connectors is, I really not recommend, I just tell you straight, use a ZP connector. If you're using something like a drop sense potentiostat, I think the banana plugs on a drop sense potentiostat are 2 millimeters. So we have a converter that will take 2 millimeter banana plugs, and it has a slot at the front which will take a 7 millimeter wide sensor. So our hypervalue electrodes are 7 millimeters wide, and therefore to attach them to something like a drop sense potentiostat, which I think has something like 2 millimeter banana plugs, then you will need one of these ones that takes the 2 millimeter banana plugs and takes the 7, and at the front of it has a slot for a 7 millimeter electrode. And again, I'll try and make sure I get these links up underneath the video during the day. And also, I would say, like, if it's a commercial business that's doing this, then also I would suggest get some support off us. If you're going to sort of move forward with this, get what we call a micro project off us, so that we can actually offer advice and give support. Otherwise, people buy this stuff, they get a little stuck. Now, within an academic setting, I understand that support is not something that's necessarily so easily purchasable. So we try to support through the webinars and stuff. But if it's commercial and you want to be a bit more professional, secretive about it, then purchase some support off us as well, like a micro project. Lastly, we did have an inquiry that came through that somebody wants to make an electrode system. Here are some of the dimensions. And because they want the gold to be less than 50 or equal to 50 nanometers, that's not screen printing. That is gold sort of vapor deposition type techniques. What I did notice is that we have, the dimensions are no problems. We already have materials on the website with these kind of dimensions. We don't have the exact object the person's looking for, but the dimensions are really no particular issue. Doing things like on a millimeter scale by either screen printing or vapor deposition are really no big issues. Something that struck me then was obviously when I look at sort of some of the critical dimensions, it's like 1 millimeter with a couple of millimeters gap in between it. This is exactly like what we have on our existing product already. And I also thought a little bit that actually our existing product, what's critical to this potential person is actually the width here and the distance here. And it's really similar to one of our products. So their form factors, they've got this large object with a couple of electrodes, but I suspect that the sensing part is right down near the tip here, which is really similar to one of our products already. The reason I bring that up is when you're manufacturing, the object that I'm looking at here is something like 30 millimeters wide and 20 millimeters width. That really is quite a large object. So I would say that this is not designed for manufacturing because it's actually too big. Often when you're doing vapor deposition of gold, it's quite a batch process. So you want to get as many pieces onto what we call a wafer at the same time. But when you make this piece fairly large, which this is, then you actually end up each batch manufacturing very few sensors. So my advice is you really need to do, there's both product design and design for manufacturing. Rather amusingly, I just had a message come through on our messaging system from our production manager. Said, yeah, we can do this, no problems. By the way, it just came through just now. So I did ask them overnight whether we could do this, and the answer is yes. But I think you need to really think about product design, and in part of that is also design for manufacturing, because the piece at the moment is too large. And my suggestion is, rather than designing a bespoke piece, I'd actually look at some of our vapor deposited gold pieces and see where any of those you could bring those to your problem, rather than designing necessarily a bespoke solution. Because as I say, just a sort of free heads up, it's quite large, and therefore you will not have a efficient manufacturing process. And it's probably worth saying that, we do this kind of consulting, which is, product design, but I think as part of product design, it's also design for manufacturing as well. So I wouldn't just go ahead with your current design. I think, talk to somebody like ZP, or consult, I would rather say, with somebody like ZP. Just as, I kind of had a feeling that these electrodes might be going to a microfluidic flow cell. So I just wanted to sort of show you that actually, it's just happenstance that I'm in Norway this week. I was talking to one of the engineers, and I saw this on his desk, and he's taken one of our electrode systems and 3D printed a flow cell, actually. It made me think that actually not only could we potentially do the electrodes, but we could also probably put the flow cell over the top of it as well. Right, so question number one. I'm just going to do a quick, let's say, summary of where we're at. Question number one, yes, you can measure sodium and potassium sensors by voltammetry. I've never done it, but I would, as a betting man, I would say, I don't bet, but as a scientific judgment, I think it could be done. I also think it could be done by impedance spectroscopy. I also think you possibly need to come to one of our workshops to really explore this a little bit more. And I think the one that's online in January might be a good one for you. Rectangular versus circular. I'm really sorry, because I know people struggle with, we make rectangular electrodes because rectangular electrodes make much more sense in products. So we're thinking ahead. In R&D, circular is great, but we're thinking about products. Put a drop on there of 0.5 to 0.9 and just spread it with a pipette tip. And if you're struggling, honestly, we do this in our workshop. So and if the inquiries from the USA, we will be setting up some workshops in the USA. Don't worry about that. We've already done one this year, but I'm thinking about one on the East Coast and one on the West Coast several times in the year. The Troponin I sensor, sure, there's a macromolecule on there that makes it specific to Troponin I, is how we do it. It's read by EAS, but it's only something that we're able to use on large customer projects. Biosensors for bioreactors, I'd say we're in the alpha stage. We will take on some beta users, but reach out to me and talk about a beta program. Measuring pH in wounds. Only this week did I kind of appreciate that actually, the difference between the pH in a wound between healthy, which might be 5, and something that's sort of got an infection, which might be pH 8 and above. That's such a big difference, actually. This is quite doable, but it does have to be done as in conjunction with Zimmer and Peacock. Measuring pH in general, go for the hypervalue electrodes, go for one of our connectors, go for the connector that has the 7mm slot on the front and 2mm banana plug connection if you're using a drop sense potentiostat, and also get some hours for supports off us. And then on the custom electrode front, I even got as I say, the response from the manufacturing manager during the workshop that actually, yes, we can do that. I would say you need to consult with us, I would say, on the product design and also the design for manufacturing, because I think the piece is just too big. It's when you're sputtering, you have a certain, certain volume in which you can put these objects and sputter upon them. So you want to have as dense an array of sensors on that wafer as possible, and your object is just a little bit too big. So design for manufacturing is something that you need to rethink about. I'll say thank you very much. I essentially apologize because I had to go quite quick today, but we do have lots of workshops going on. So I will say thank you from my side. And if you've got any questions, reach out to us at Zimmer and Peacock, and we will essentially cover them in this workshop again. All right, have a good rest of the day, and I will speak to some of you next Thursday. Take care. Bye-bye.